Hi, this is your last section for the trig class. This is the cross products. In addition to the dot product, there is another type of product of two vectors. The additional product called the cross product applies only to three-dimensional vectors, also called vectors in space. Vectors in space. I just think that sounds funny. Anyways, unlike the result of the dot product, which the result is a scalar, which is a single number, the cross product of two vectors results in a vector. Okay, this is quite handy. You'll use this probably in calculus too, by the way. For this reason, the cross product is sometimes called the vector product, which makes sense. Okay, the cross product of vector v cross vector w equals v cross w. That's how that's read. So v cross w. It is the determinant of a 3x3 matrix that is set up as follows. So the top row consists of the components of the unit vector I, j, and k. And then the middle row is going to be your first vector's components. So a1, b1, and c1. I want you to notice that we're looking at the values in front of I, j, and k, and that's what's going to go into the setup. The bottom row consists of the components of vector w of a2i plus b2j plus c2k. So we're just going to write down a2, b2, and c2. Notice that the vertical bars around the matrix indicate that you must find the determinant of the matrix. Okay, there's a couple different ways to find the determinant. You can either use the basket weave method, or you can use what's called the Minor's methods. That's a method that is explained in the textbook. Personally, I like the basket weave method, and that's what I'm going to show you. So we're going to use the basket weave method, and when I work out some of the problems in this section, I'm going to be using the basket weave method. So to find the determinant using the basket weave method, you start out by writing the first two columns of the right of the original cross product matrix. Then you take the products of the three primary diagonals going from left to right and sum them up. Then you take the products of the three secondary diagonals going from right to left and sum those up. The answer to the determinant is the first sum minus the second sum. Okay, once again, product means we're going to multiply things together. So you're going to multiply the values of the two vectors together, and we're going to see how this works out. So let me go ahead on to the second page here. So the first thing you're going to do is you're going to work left to right, and that's going to give me sum number 1. So I'm highlighting that. I'm working on sum number 1. So I'm going to take the I components and multiply it by B1, C2. Okay? Then I'm going to take J and multiply the C1 and A2 components together. And then I'm going to take the K and multiply the A1 and B2 components together. That's why you have to write out I and J columns right next to it so it works out. Okay? For the second summation, let me erase this. For the second summation, you're working right to left. So I'm working on these three that I just highlighted. Okay? So if you want to read them off, for instance, the J component is going to be A1 times C2. The I component is going to be C1 times B2. And the K component is going to be A2 times B1. Okay, so that's how we do this. And once we get the second sum, we're going to take sum 1 minus sum 2. Okay, so that's how this works. So let's just look at it really quickly. And when we take sum 1 minus sum 2, you're going to add any like terms. And then you're going to come up with a vector as a result. Okay, there's some animation demonstration of the basket weave method. Hopefully the link still works here, but go ahead and check it out. And let's move on. The other thing I want to talk to you about before we start working on things is if you have a 2x2 and you're asking to find the determinant of a 2x2 matrix, all you have to do is you multiply A1 times B2 and then subtract A2 times B1. Okay? So that one's much easier than a 3x3. And by the way, the directions that follow tell you how to do the minor method. So you get to pick, like I said, whichever one you want to do. You should get the same results. Okay, so let's go ahead and move on. So it is your choice whether you use basket weave or minor's methods for evaluating a determinant. You do not need to learn both methods. Just pick whichever one makes you happy. Okay, so let's look at example 1. What I'm going to do is I'm going to label these. So this is A1. The 2 is going to be A2. And then B2, or B1, sorry, and B2. Okay, so basically what I'm going to do is I'm going to multiply A1 times B2. And when I do that, I get... sorry, let me just do this really quick. I get -2 times -3, and I'm going to subtract the other direction, B1 times A2. So I'm going to subtract 5 times 2. Okay, so all I did was I did crisscross applesauce, right? I did these two, and then I did these two. Okay, when you do that, you get 6 minus 10, which gives me a -4. Okay, let's move on to the next one. So once again, we're going to multiply the 6 and the -1 together. And then we're going to subtract off 5 times -2. And when I do that, I get -6 minus 10. It gets -6 plus 10, which equals a +4. Okay, so I got those two done. Let's look at example 2 together. Example 2, find the cross product of vector v cross vector w of the given vectors. Now we have a 3x3 matrix. Okay, so if you use the basket weave, you have to be very careful to make sure it's nice and neat. And keep your rows pretty constant. It'll help you out. Okay, so my first row is I, J, K, and then I repeat I and J. And the reason why is because I need to have all 3 values on the diagonal. Now I'm going to look at the coefficients of vector v, and I'm going to place them down. So in front of I is a negative. So I have a negative coefficient of -1. The second one in front of J is a +3, so I write down 3. And then in front of K is a 2. Okay, I'm going to move down to vector W. The coefficient in front of I is 3. The coefficient in front of J is -2. And the coefficient in front of K is -1. So I'm going to repeat the first 2 columns. I'm going to put -1, 3 here, and then 3, 2 here. Okay? So now I'm going to work on sum 1. So sum 1 means we're going to have to take and multiply along this row. So I. So we have 3 times -1 I. Okay. Plus, let's see what J turns out to be. J is 2 times 3. J plus K. K is -1 times 2. Okay, so we're going to make that look a little bit nicer. 3 times -1 is -3i, plus 2 times 3 is 6j, and then -1 times 2 is -2k. Okay, so that is sum 1. So let's work on the sum 2. Okay, so sum 2, we're going to go the opposite way. So I'm going to use a different color here. Bear with me for a minute. I'm going to use purple. Okay, so I'm going to go for J, which is right here. So J is -1 times -1 plus, I'm going to do I next. I get 2 times -2 plus K is 3 times 3. Okay, simplify this down. I get 1J minus 4I. 3 times 3 is 9, so I get plus 9K. So this is sum 2. Okay, now the directions tell me that I have to add any like terms together to get the resulting vector. So what we're going to do is we're going to take sum 1 minus sum 2. Sum 1 is negative 3i plus 6j minus 2k minus j minus 4i plus 9k. Guys, I found a little mistake I made. When I was doing k of sum 1, I should actually have a negative 2 right here. Let me put that in there. So there should be a negative 2 here. So this gives me a positive 2k. So I'm going to fix that really quick. There we go. Alright, I always check my work. It's a good thing to do because if you miss a little thing like a little negative sign, it can throw everything off. Okay, so I have negative 3i plus 6j plus 2k minus j minus 4i plus 9k. Now I'm going to combine like terms. But before I do that, let's go ahead and distribute that negative. So I get negative j plus 4i minus 9k. Okay, what does this equal? I'm going to add the i's together. So 4i minus 3i is a positive 1i. J's. I have positive 6j minus j is 5j. Okay. And then k's. I have negative 9k plus 2k is negative 7k. So the resulting vector is I plus 5j minus 7k, and that is your answer. Okay. Alright, so that's how you use the basket weave method. You just got to be careful. Watch your negative signs and make sure that you line things up nicely. If you do, it's much easier to do. And the next video will show you how to do part B, and then the next example. So there's probably going to be 3 videos total.